Hello everyone. Today we are going to discuss recursion and recursive algorithms. Let me share the presentation. Okay. Recursion. We can give an example for recursion as Matrushka, Russian dolls. In Russian dolls, when you open one, you can see the second one. And when you open the second one, you will see the third one. So it will continue till to get the empty Matrushka doll. It is actually, we can call it recursive nature. Today, we will describe the recursion, then what is base case, what is the recursive case, and also the other important topic, excessive repetition in recursion. We will learn that, and how can we decide which one is better, recursive algorithms or iterative algorithms for some specific problems. Recursion is a technique in programming where a function calls itself. It is very simple and basic. If any function or algorithm calls itself, we call it a recursive algorithm. For example, here, the biggest function, and it calls itself, so we can say directly it is a recursive algorithm or recursive function. We can see recursion in our environment, in our around. For example, Sierpinski's triangles or recursive contour, mystic shape, or this cartoon. These are recursive nature. Okay. How can we create recursive algorithms if we can reduce the size of problem to smaller problems with the same form? We can create recursive algorithms for that problems. And it can be a powerful tool for solving problems that have a recursive structure. So two terms are very important to be able to reduce smaller problems with the same form. For example, factorial. Yes, we can reduce the size of problem from n factorial to n minus 1 factorial and with the same form. So we can write recursive algorithm for a factorial problem. And using that factorial recursive algorithm, we can calculate or we can get same results with the iterative factorial algorithm. Yes, this is a factorial function. When we run it, and for factorial 5, what will we see? This is an important point. If we run it, we will get an error. It is maximum recursion depth exited error. Why? Because in this function, we don't have base case. There is just one recursive case, no base case. That's why it will call itself infinitely. When it calls more than 2970, it will give maximum recursion depth exited. Or in other words, stack overflow error. Because it will call factorial 4, then 3, 2, 1, 0, then negative 1, negative 2 through the negative infinity. So it must have a base case and recursive case. This is very important. For example, when we run it, a factorial algorithm for factorial 5, it will call factorial 4. Then it will call factorial 3, 2, factorial 1. It is base case. Finally, when we reach the base case, it will calculate directly all the factorials and finally factorial 5. And the result is 120. If we run for factorial 3000, it will give error because each programming language has limitation. For example, Python has a limit of 2,970 function calls. So if it exists, this number, it will give maximum recursion that existed in comparison error. Also, we can write iterative factorial function using just one for loop, and we can get the same results. So the question is when we can prefer recursion or iterative algorithms. There are three main issues about this. One is memory usage, because recursion can be memory intensive. On the other hand, iteration typically uses less memory. So it depends on our problem type, and our memory limitation. The second item is code complexity. In general, recursive solutions can be easier to read compared to iterative solutions, because iterative solutions may require more complex code. The third item is performance. Recursive solution can be slower, and sometimes it can generate stack overflow errors. However, some problems may be better suited for recursion and may have faster recursive solution than iterative ones. So when we decide the recursive or iterative algorithm, to design an algorithm in recursion or iteration form, we have to consider these three items: memory usage, code complexity, performance. Okay, there is one activity. Let's write a recursive algorithm, recursive function for computing power. This is the base case, and this is the recursive form. So initially, we can write base case, then recursive case. What is excessive repetition in recursion? When recursive algorithms are designed carelessly, it can lead to very inefficient and unacceptable solutions. Why? Let me give an example: Fibonacci sequence, Fibonacci numbers. And to calculate a Fibonacci number, we need to add previous two Fibonacci numbers. And the base case is Fibonacci number 1 and Fibonacci number 2 is 1. Okay, so this is the recursive function of Fibonacci. But when we compute these Fibonacci numbers, for example, Fibonacci number 4, we need to compute Fibonacci number 3. To compute the Fibonacci number 5, again, we need Fibonacci number 3. So in this algorithm, we need to compute any Fibonacci number more than 1 times. So we call this process excessive repetition. Here, this graph displays explicitly the same problem. For Fibonacci number 5, we need to compute Fibonacci number 3 here and Fibonacci number 3 here again. How can we avoid this problem? Using memorization technique. In memorization technique, we use a cache list, and we store each Fibonacci numbers computation after the computation in this list. And whenever we need to compute a new Fibonacci number, we check the Fibonacci this cache list. According to the search, we can compute the Fibonacci number, or we can skip that. So this technique is called memorization technique. Here, instead of computation of Fibonacci number 3, just we use 2 because it is computed before and it is in the cache list. As a summary, we can define recursion if function calls itself. And each recursive algorithm must have base case and recursive case. Stack overflows happen when you make too many function calls without base case. Also, anything we can do with recursion, we can do with a loop or iterative form. These are the supportive materials. And in the next lecture, we are going to learn how can we analyze recursive algorithms. Thank you for your attendance. See you on next class.